And good morning, students. I welcome you all again for the science lecture. And as we are studying from last 3 days, the same lesson, and the teacher is also the same. That's me, and you can see my name on the screen. That is Pathan Arifa Khatun. I'm from Worli Face English Municipal Secondary School, and we are here for science and technology. That is paper 1. Now, as in the last chapter or the last topics, we all know we have started with lesson number 5, that is acids, bases, and salts. And initially, we have covered 2-3 topics. Like the starting lecture for this lesson was just a revision only about some basic questions. Like we have studied about the litmus paper. How does the litmus paper shows us that the particular solution is acidic, the particular substance is basic. So I have given you many examples, and though you were knowing initially, but we have again revised that, and I hope you remember it about the litmus paper. Then after checking the different substances with litmus paper, we have come to know that the substances which we use, or whatever the things which we use, they are classified into 3 types, and that is nothing but the name of our chapter, that is acids, bases, and salts. Then after that, we have also seen some ionic compounds. One ionic compound that's very good example for sodium chloride, NaCl, and I have shown you through various examples also how the sharing and donation of electron takes place between sodium and chlorine. So that was about the ionic compound. Why it is called an ionic compound? Because it contains opposite charges. It contains opposite charges, that is the positive one is the cations and the negative one is the anions. So that is why they are called as the ionic compound. So after that ionic recapitulation, we have also seen about the dissociation of ionic compound. Like when we dissolve salt in water. So what does happen? We have also seen the initially the solid particles, they remain stuck at one place only. But as it goes on dissolving, it goes on dissolving. The water molecule push them, and in that way, the Na plus cations and the Cl minus anions, they get separated. After that, we have also seen about the Arrhenius theory of acid and bases, definition of acids and bases, and then after acid definitions of acids and bases, we have also seen about the classification of acids and bases. And I'm sure okay, you are now clear with the 2 types of acids, that is the strong acids, weak acids. Likewise, bases also 2 types, strong bases and weak bases. And I have given you one hint also to remember you. Okay, if you just remember the strong acid and weak acid, you could answer the strong bases also and weak bases also. That is important. Then after that, and last we have concluded with the basicity and acidity of acids and bases. It was also vice versa, if you remember it. And now today we are here for concentration of acids and bases. Concentration of acid and bases. Uh, I hope you all are carrying your textbooks with you all, and the screen which you can see here. So this 5.3 or this picture has been taken from textbook only, because it is easy for you also to correlate it from the textbook. When you see in the textbook, you could easily understand ki, chalo, this one is going on. So now what we are studying, concentration of acid and bases. Here you can see 2 bakers are there. 2 bakers are there, and let us now know okay, what has been happening here. Let me tell about the baker to you. What is a baker? It is a laboratory equipment, laboratory equipment which we use for performing some different types of science experiment. So it is made up of glass, and you could also see a scale over there. 0 ml, then 5 ml, then 10 ml, 15, 20, 25, likewise. Maximum it is up to 30. 30 or max to max it will be up to 50 accordingly. So both of them are same only, but the solution in them is different. So this was about the scale of the baker, and why the scale is given, so that we can take whatever the amount of solute or solution we need to take. So what we have done in this two bakers, cut a lemon in two equal parts. We all are aware of lemon. We use for cooking, for enjoying different recipes. Lemon, simple lemon, cut into two equal parts. Take the juice of each part into two separate bakers. Half half that lemon. Take the juice in both of these two bakers. One half part in beaker number A and one half part in beaker number B. Pour 10 ml of drinking water in one baker and 20 ml of mm, 20 ml of water in the second. In the first baker, 10 ml of water, drinking water. And in the second ml also, water. But how much? 20 ml. Stir the solution. Stir means take a glass rod, a like your stick. Stick is made up of wood. But in the laboratory, a glass rod is used. It is made up of glass, and it is a very thin one, uh, which is used for stirring the solution. Stirring means to mix the solution. Stir the solutions in both the baker and taste them. Baker number A 10 ml, baker number B 20 ml. And in both the bakers, we have added half cut lemon. Now taste the baker number A, taste the baker number B. Okay, after testing, could you see any difference in the taste of the solutions? What is the difference? If you'll test both of them, you could find a difference over there. What is the difference? In the above activity, the sour taste of the solution is because of the solute. In the above activity, the sour taste is because of the solute. What is the solute now? The solute is, who is the solute now? We are going to see that. In the above activity, the sour taste of the solution is because of the solute lemon juice in them. To the whatever the taste you are now feeling, it is because of the lemon, and that lemon is called as now, or that solution of the lemon which we have squeezed it and that some lemon juice came out of it. So who is the solute now? Lemon juice. The quantity of the lemon juice is the same in both the solution. Lemon juice is same. Baker number A, half lemon, half cut lemon squeeze. Baker number B, half cut solution of lemon juice, same. Yet the taste is different. Yes, the taste is different. The solution in the first baker is more sour than the one in the second. Simple, no? The solution in baker number A will be more sour than in B. Why is it so? Although the quantity of the solute is same in both the solution. Solute, lemon juice, quantity is same in both the solution. The quantity of solvent is different. Who is the solvent now? The water. Beaker A, 10 ml. Beaker B, 20 ml. So the quantity of solvent is different. The quantity of solute is same. But yet solution A or Beaker A is tasting sour. Beaker B is tasting less sour. Ratio of the quantity of the solute to the quantity of the resulting solution is different. Yes. Half lemon juice, both sides. But the ratio of that lemon juice in A to the ratio of that solvent is different. And here, for both the cases, it is different. The ratio is larger for the solution in first beaker. Yes, the ratio is larger for just for that lemon juice. That means lemon juice is in a less quantity than 10 ml. For B, lemon juice is very less than 20 ml. The ratio is larger for the solution in the first beaker and therefore the solution tastes more sour. On the other hand, the proportion of lemon juice in the total solution in the second beaker is smaller and therefore it tastes less sour. Now the taste of all foodstuffs, whatever we eat, depends upon the nature of the taste giving ingredients and its proportion in the foodstuff. Now sometimes it happen in our houses, okay, the tea it becomes very sweet, or like any sabji whatever we make, or any snacks item which is prepared at home or we bought from outside, sometimes it tastes very salty. What is the reason here? Okay, whatever the thing which is giving the taste to that particular ingredient. So the if the proportion exceed, if the proportion exceed of that particular uh, ingredient, the taste changes. Similarly, all the properties of a solution depend on the nature of the solute and solvent. So all the solution, whatever we use, all the solution, liquid solution, they also depend upon the solute and the solvent. The proportion of a solute in a solution. The proportion of a solute in a solution is called concentration of the solute in the solution. There's no need to get confused. Just look at beaker A and try to understand the concentration of the solute. What is it? The proportion of a solute. Half lemon juice, half cut lemon juice we have added in beaker A. So who is the solute? Just we have to remember solute and solvent. Solute in this experiment is the lemon juice. Solvent is water. So the proportion of solute in a solution is called concentration of the solute in the solution. Concentration, the amount in that particular solution. When the concentration of a solute is high, it is a concentrated solution. Like here we can say that the particular given solution in A is concentrated. When it will be known as concentrated? When the concentration of solute will be more. When the concentration of solute will be higher, more, it will be known as concentrated solution. When the while the solution is dilute, is called a dilute solution. When the concentration of solute is low. When the solution, while the solution is called a dilute solution. When it will be known as dilute? When the concentration of the solute will be less. Like very simple, like the solution in beaker A is concentrated solution. The solution in beaker B is dilute solution. Reason behind this is K. In beaker A, the concentration of solute is more. In B, the concentration of solute is less. Several units are used to express the concentration of a solution. Various units. Now A and B both are solution. Certain units are used to express them. Two of these units are used more frequently. There are two units. The first is the mass of solute in grams dissolved in 1 liter of a solution, that is grams per liter. 1 liter water and the amount, the grams, like 20 grams, 25 grams, 30 grams per liter. It could be more also. The second unit is the number of moles. The first unit is grams per liter. Just remember this. There are two units to measure the solution, to measure the concentration. That is, first one is grams per liter and the second unit is the number of moles of the solute, which is dissolved in 1 liter solution. This is called as the molarity of the solution. It can be asked for definition. Define the term molarity. What is molarity? The number of moles of the solute, dissolved in 1 gram of solid, dissolved in 1 liter of the solution. That is the molarity of the solution. The molarity of a solute is indicated by writing its molecular formula inside a square bracket NaCl. For example, NaCl. Square bracket, like mostly we use round bracket. Then in square bracket, we could write the molarity of a solute, like example, NaCl in bracket is equal to 1. Means the molarity of solution of common salt is 1 molar. Definition of the molarity of the solution: the number of moles of the solution dissolved in 1 liter is called molarity of the solution. We have gone through this. Now, this table is given on page number 23, and here it is given K, the concentration of various aqueous solution. Now, we are familiar with the word aqueous solution. Aqueous solution, we are learning it from last 2 lectures. Aqueous solution, how it is prepared and why it is said to be aqueous. So the table which is on page number 63, it is about the concentration of various solutions. The first one is the ABC, that is the solute. Second is the quantity of solute. Third is the volume of solution, concentration of the solution. Like first one is given case sodium chloride. 1 molar, just now I said sodium chloride. So molecular formula of sodium chloride is NaCl. Molecular mass of total molecular mass of sodium chloride 58.5 nu. 58.5. Quantity of the solute. Quantity of the solute, like if we'll take 2, if we'll multiply that molecular mass by 58.5 into 2, it will be add up to 170. So it is in grams in grams, it will be 117 gram. Okay. Then how much mole it will be? Because we have taken D upon C, that is 117 upon 58.5. So it comes up to 2 moles. Then volume of the solution means in liter will be 2 liter. And again, if you divide D upon F, that is 117 upon 2 liter, it will again become 58.5 grams per liter. And the molarity of the solution or moles per liter will be 1 mole. Likewise, another example is for hydrogen chloride. Hydrogen chloride, the molecular mass of hydrogen chloride is 36.5. Likewise, you can calculate. Then this is sodium hydroxide. So sodium hydroxide, first you have to write the name, and the molecular mass of sodium hydroxide is 40.4. And in this way, you can calculate. Just you have to put the values. And here you have to, the E will be D upon C, G will be D upon F. In this way, you could solve it. So this is the concentration of different aqueous solution. Different means just 3. There are many solutions, there are many substances. Here it is given taken examples for sodium chloride, hydrochloric acid, and the third one is sodium chloride. Next topic is the pH of solutions. Different solutions we have, different things we use, different substances which are made up of matter. The things which we use, they are made up of matter, and that is why they have a particular shape also. And all different substances, they have taste also. And there's one very important one important concept behind that is the pH of solutions. I don't know whether you know about the full form of pH or not, but I will tell you. It is potence of hydrogen, or concentration of hydrogen also we can say. But from the symbol or from the alphabets, you can say potence of hydrogen. Now, what is the pH of solutions? Now we have seen, देखो, कि acids and bases dissociate to a smaller or larger extent on dissolving in in water, forming H plus and OH minus ions respectively. If it is acid HCl, when it dissolves in water, it will give you H plus and Cl minus ion. Acid. If it is a base like NaOH, KOH, and AOH is your sodium hydroxide, KOH is your potassium hydroxide. It is a base because its acidic radical is OH. It is a base, basic solution it is. So when they dissociate in water, dissociation we have seen, no? Dissociation of ionic compounds. So what does they give when acid will dissociate or dissolve in water? It will give us H plus Cl minus ions. When base will dissolve, it will give us Na plus OH minus ion or K plus OH minus ion. Likewise, so H plus and OH ions are found in different proportions in all the natural aqueous solutions and that determine the properties of solutions. Most of the substances they contains H plus and OH minus ions only. Most of the substances like acids and bases, whereas salt they does not contain. Water, we have also seen salts. Okay, salts are those ones which have a basic radical other than H plus and acidic radical other than OH. So that are salt. So we are not will not talk about them. But we are talking here about the H plus and OH minus substances which have H plus and OH minus. So there are these two ions are found in different proportions in all the natural aqueous solution like water. The example here is given for water. H2O is a natural substance, water is a natural substance, and here also see how the ions are formed from the molecule of water. Clearly you can see when when water is dissociated. So what is formed? H plus and OH minus. H plus and OH minus ion. Since we are studying here the pH of solution, so you could be thinking ki why ma'am has taken this one H2O. It gives you H plus and OH minus ion. Now for if you'll talk about this, you'll come to know the proportion of H plus and OH ions divides soil into the acidic, neutral, and basic type of soil. The soil we all know, the earth, which is made up of soil only mostly, which contains or which have a large proportion of soil. So the proportion of H plus and OH minus ions, they decide or they divides the soil into acidic, neutral, and basic type of soil. That means there are three types of soils: acidic soil, basic soil, neutral soil. It is necessary for blood, cell, sap, etc. to have H plus and OH ions in different or in certain definite proportion for their functioning. See, the blood in your body, it should have a proper or a definite proportion of H plus and OH minus ions so that our body performs or runs smoothly for all the functions which takes place inside our internal functions which runs continuously in our body. Fermentation carried out with the help of microorganisms, other biological processes, and also many chemical processes requires the proportion of H plus and OH minus ions to be maintained within certain limits. So in short, we can say that whatever the biological processes, the chemical processes, the fermentation which is carried out with the help of microorganisms. See, microorganisms are the ones, they are also living ones, but we cannot just arrange, they're not visible with our with our naked eyes. We just can see them with the help of uh, microscopes. So fermentation example I will give you, very common example. Okay, that is we prepare idli and dosas at our home. So our mummy, what does she do? She prepare a batter before night, that is the day before actual when you want to eat, and all that overnight, that particular batter, that idli dosa batter or that atta is kept. It is kept for what purpose? For fermentation only. I'm giving a common example so that you could understand what is fermentation. So that atta or that batter is kept throughout the night. Fermentation takes place and it rises. It rises sometimes above the dibba also. It rises above that particular vessel in which it is kept. So what is happening there? Fermentation is happening there. And for this fermentation process also, the particular amount of H plus and OH minus ions are necessary. It requires a certain limit. So pure water also undergoes dissociation to a very small extent and give rise to H plus and OH minus ions in equal proportion. The example which you are seeing here. So due to this property of water to undergo dissociation, there exist both H plus and OH ions in any aqueous solution. However, the concentration may be different. For water case, for water, it is the proportion of H plus and OH minus is the same. They both are equal. But for different aqueous solution, it is different. The proportion, that means H plus may be different. The number of H plus may be different. This also I have taken in the earlier lecture. Like there was a table and some acids and bases were given. And I have told you, count the number of H plus ions and count the number of OH minus ions in the given examples. है ना? So therefore, in this way, the concentration differs. The picture you can see on the screen is again from your text one only. It is the table which is showing you some common uh, examples, and all those examples are of aqueous solution and their pH. That means the potence of hydrogen or the presence of hydrogen also we can say. The presence of hydrogen. Now, see, you can also see arrows over there. One arrow is like moving upwards, and one it is going downward. So all that which is like from the acid rain up to the 1 ml HCl, they all are acidic solutions. Then in the middle, that urine, rain, milk, they are the neutral solution. Weak acids up one, neutral one is the rain, milk, and the downside when you will come from the pure water, sugar solution, blood, they are all the weak bases, that line. And when you come downward, they are the strong bases. So this, and with the different examples, each one's pH is also given. Like 1 ml HCl, the pH is 0.0, nothing. Gastric juices, they are formed in our body when digestion of our food takes place. That is 1.0. Lemon juice, 2.5. The pH of lemon juice is 2.5. Vinegar, it is 3.0. Tomato juice, 4.1. Black coffee, 5.0. Acid rain, 5.6. Very high, strong acid, like you can say. And next one is the urine, 6.0. Then at one point, you will come to know it is 7. So when it is 7, that means it is neutral. Then different substances are again given there. It's about the bases, like the blood solution of baking soda, it is 8.5. Strong base it is. It is strong base. Then toothpaste, 9.5. Milk of magnesia, 10.5. Lime water, 11. 1 mole of NaOH, 14.0. Strong base here. So This is just the pH of the solution. We'll discuss it later with some other pick. Now here the concentration of H plus ions. Concentration of H plus ions. So the concentration of H plus ion formed by dissociation of water. When water is dissociated at 25 degree Celsius, so it is 1 into 10 to the power of minus 7 moles per liter. मतलब कि 1 liter. When water dissociate, when 1 liter water dissociate, the concentration of H plus or the presence of H plus ions is 1 into 10 to the power of minus 7. And if you'll take at the same temperature, the concentration of H plus ion in 1 ml HCl. Earlier it was water. Now it is HCl. The temperature is same, 25 degrees Celsius. Concentration of H plus ions will be 1 into 10 to the power of 0. 10 to the power of 0, that means nothing. Moles per liter. While in a 1 mole NaOH, whose pH is 14.0, that is only 14. So while in a 1 molar NaOH solution, the concentration of H plus ions is 1 into 10 to the power of minus 14 moles per liter. So see, now we have seen all three slides here. First one was for water, for 1 liter water. Then second is the 1 mole of that was 1 molar solution of HCl. Here 1 molar solution of NaOH. Three different solutions. Thus we see that in common aqueous solution, the range of H plus ions is wide. It is different. For water it is 1 into 10 to the power of minus 7. For HCl it is 1 into 10 to the power of 0. And for NaOH it is 1 into 10 to the power of minus 14. Different, wide range. It is very wide, from 10 to the power of 0 up to 10 to the power of minus 14. So in 1909, the Danish scientist Sorensen introduced a convenient new scale of expressing H plus ions concentration, which was found very useful in chemical and biochemical processes. That was called as the pH scale. It is the power of hydrogen. Hydrogen का power कितना है? It is the power of hydrogen, pH. The pH scale extends from 0 to 14. I will be showing you. The pH scale extends from 0 to 14, and according to this scale, pure water has a pH of 7, meaning pure water has H plus, that is 1 into 10 to the power of minus 7 moles per liter. pH 7 indicate a neutral solution. You will come to know here. This here. Again, it is taken from your textbook only. The upside one. Right side, up one, where you can see the numbering 1 to 14. At 7, at the number 7, the solution which shows the green color, which is at number 7, particular solution, aqueous solution, whatever the substance it will be neutral. So pH number 7 shows the given solution is a neutral solution. This pH is the midpoint of the scale. This pH is the midpoint of the scale. The pH of acidic solution is less than 7. Less than 7 means left side, like 6, 5, 4, 3, 2, 1, or 1, 2, 3, 4 up to 6. So when the scale shows the substance and that particular substance, color of the substance matches with this numbers 1 to 6, you could easily identify, or you can tell it is an acidic solution, and that of a basic solution, it is greater than 7. When you move right, 8, 9, 10, 11, 12, 13, 14, and if you check that particular substance solution with this numbers or with this colors, you immediately come to know the particular solution is a basic solution. So the table 63, just we have earlier seen, it gives the pH values of some common solution. So you got, and already it is given only there, only the pH is given. When you will match the pH number with this scale, you could come to know the particular, like if we'll take the one example of pure water or sugar solution. sugar solution. You will come to know, okay, if the number is given 7.0, then that means pure water is neutral. Sugar solution at 7, it is neutral. In this way, you can go through it. Now here you may be thinking there are also some other devices also like other than the pH paper. So these are all the universal indicators. These are all the universal indicators. Now, what are the colors of the following natural and synthetic indicators in acidic and basic solution? Now, this will come to know when we'll check them physically only. We know that some natural and synthetic dyes show two different colors in acidic and basic solution, and such dyes are used as acid base indicator. In the pH scale, the pH varies from 0 to 14 according to the base or the acid. To show these variations in pH, a universal indicator is used. A universal indicator shows different colors at different values of pH. The universal indicator, it is also used to show the pH only. So it is used to show different colors at different values. Actually, the universal indicator, it is made by mixing several synthetic color, artificial color in a given proportion. The pH of the solution can be determined by means of universal indicator. Universal indicator solution or the pH paper made from it. Like pH paper is also made from the universal indicator. However, the most accurate method of measuring the pH of a solution is to use an electric instrument called the pH meter. See here. This one is another slide. I will explain you this one also. See, these are the examples given here: tomato, like your human urine, pure water, then the human blood, then hand soap. The hand soap or baking soda also it was given there because it is a basic solution. Household bleach. So the number immediately will make you understand if the pH is 2. You could say the particular solution is acidic. If the pH is 7, the number you should see it is neutral. If the pH is 10, you could tell the solution is basic. We were talking about the pH meter. This is the pH meter, and you could see the solution. The left side one, green one, that is the solution, and immediately it shows the reading there. So if you get the number, you could easily identify it by the number, and with the help of the pH paper numbering, the particular given solution is acidic, and sometimes it is basic, and sometimes it is neutral also. This is the pH meter, and it is very useful electrical instrument which is used to measure the pH. In this method, pH is measured, or pH is calculated or identified by in the solution. Electrodes of the particular whatever they are made up of, when they are dipped in this solution, it gives you the color. The color is due to that electrodes only, and from the color you could identify that. Okay. Now the next is the reactivity of acids and bases. See here, dilute HCl. Neutralization reaction is this. You have taken HCl in water, then it becomes a diluted solution. Here, hydrochloric acid is less and water is more. Therefore, it is a diluted solution, and the acid was taken as HCl. Indicator strip. This is a pH indicator only. When you mix the solution, this is the glass rod, and you take that particular solution, you check on the pH paper, you come to know, okay, by the color which is shown on the pH paper, the particular solution is acidic. So now in this example again can be understood by the ionic reaction, that is HCl plus NaOH. It gives you NaCl and water. Cl and NaOH. That is a one acid and one base. Yes, one acid and one base. HCl is acid, NaOH is a base. So when they both are uh, mixed into each other, we get NaCl, salt and water. So it can be seen from the above equation. Okay, Na plus and Cl minus ions are on the both side. Therefore, the net ionic reaction is H plus OH gives H2. Since both Na and OH are both side, therefore Na and Cl. Therefore, the actual ionic reaction is NH plus OH minus ion gives you H2. As NaOH solution is added drop by drop to the HCl solution, the concentration of H plus goes on decreasing due to the combination with OH minus ion, and that is how the pH goes on increasing. And when enough NaOH is added to HCl, quantity is same. The resulting solution contains only Na plus Cl minus ion, that is NaCl, a salt and the solvent. The only source of H plus and OH minus ions in this solution is dissociation of water. Therefore, this reaction is called neutralization reaction. The neutralization reaction is also represented by simple equation like acid plus base gives you salt. Acid is NaCl, base is NaOH. Salt is given through the reaction on product side or on the right side, that is NaCl and water. Now, some of the common neutralization reaction in your textbook it is given, and we have to write the names of the acids and write down the names of acid, bases, and salts in it. You could see the examples like HNO3 is your nitric acid, potassium hydroxide KOH. So it gives you salt and water, potassium nitrate. It is. Now, second one is the sulfuric acid. Then third one is the hydrogen bromide, bromic acid also. And in this way, the equation is given. Like now, the next and the last one, reaction of acids with metals. The reaction of acid with metals is determined by the strength and concentration of the acid and also by the reactivity of the metal. Like the reactivity of the metal is less or more, and the temperature also depends. It is easy to bring about the reaction of a dilute solution of strong acid with moderately reactive metal at normal temperature. Some examples are given. Metal plus dilute acid, it will give you salt and hydrogen. All time you will get salt and hydrogen only. So, when metals react with acid, they give us salt and hydrogen. Different examples have been given here. Uh, First, it is in common form, like metal plus dilute acid gives you salt and hydrogen. Then the second one is magnesium. Magnesium is a metal and it is taken in a solid form. And HCl in aqueous form, it is taken diluted form. So it gives you magnesium chloride plus hydrogen. So likewise with zinc and copper, it gives zinc sulfate and hydrogen. With copper also, copper nitrate and again hydrogen. Okay, so I hope okay, you could have understood this, and that was the part which I have taken extra because it was just included in this all slides. And here we can uh, stop here with today's lecture. And but before stopping, as you all know, okay, we go through some evaluation part. So I have taken some questions which could be important from uh, exam point. Okay, like the first question is the short, these are all short questions. Answer the following questions. First one is the what is molarity? We have gone through this when we have studied with concentration of acid and bases, solute and solvent, and it is given, I think, on your textbook page number 62, last para. Okay, the molarity of the solution, it is the number of moles of the solute dissolved in 1 liter of the solution. Write the water dissociation reaction. Water dissociation reaction. So simple. You should know the molecular formula of water, H2O. When water is dissociated, we will give an arrow, and on arrow we will write down dissociation. So when water get dissociated, there is what happens? The hydrogen and H plus ions and the OH minus ions, they get distributed. So H2O on dissociation gives H plus and OH minus ions. Then the other one or the last one is the what is neutralization reaction? Explain with example. What is neutralization? Just we have gone through this. Okay, when acid and bases react together, they form salt and water. They salt and water, and this is called as neutralization. And for example, if we'll give the common or the very easiest example is acid HCl plus base NaOH. Yes, after putting an arrow, if you are giving the example, we have to write the chemical reaction also and plus their names of that compounds also. So HCl plus NaOH, it gives on the product side NaCl. NaCl is a salt or common salt also we can say. Magnesium chloride is also a salt, but we will take the acid will be different, but the reactants will be different for that. So HCl plus NaOH gives NaCl plus H2O. So this is an important question. What is neutralization reaction? Explain with example. It will be helpful for you in 10th standard also. You should know the neutralization reaction, and if you just remember this easiest example, it will be very helpful for you for your next standard also, and for this, at least for this standard also. Okay, I hope so. Okay, all you have understood this lesson, and with all this, I wind up for today. And also at the same time, I thank you all for joining the lecture and wishes you a very good day. And stay home, stay safe, and enjoy your online learning. Okay, so that's all for today. Thank you.
Yes, teacher. Thank you so much.
Okay, sir. Thank you.
थैंक यू एवरीवन. इसी के साथ हम आज के लेक्चर से ही पे वाइंड अप करते हैं. मिलते हैं टुमारो मॉर्निंग 8 o'clock. गुड बाय एवरीवन.